Dear student, Assalamu alaikum and welcome to e-learning Al Noor International School grade 9 chemistry course. I'm your chemistry teacher Fraz Anjum. Today we will discuss chapter number 7 which is new chapter, says ionic and metallic bonding, and in this chapter lesson number 1 which is ions. For this you need to open textbook page number 194 till 199. Our main objectives for this lesson are: determine the number of valence electrons in an atom of a representative element. Number 2, identify the atoms of elements that tends to lose and tends to gain the electrons. And 3, describe how cations form and explain how anion forms. Before I start, we discussed last week that what is valence electrons. One more time, valence electrons are the electrons that in highest occupied energy level of an element, which is outermost electron. Remember this, which is outermost shell. Okay, outermost shell. Okay, the number of valence electrons largely determine the chemical properties of an element. So start with this. What is valence electron and how do you find the number of valence electrons in an atom of a representative elements? So answer is, to find the number of valence electron in an atom of a representative element, simply look at its group number. Such as, open your periodic table please. Okay, after opening you can see that 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So the number says it's valence electron. Means in group 1, how many valence electron? 1. In group 2, how many valence electron? 2. Group 3, 3. Group 4, 4. Group 5, 5. Like this. Okay. So what is the number of this group? Like a group 1. So how many valence electron? 1. Okay. Remember this. So like this, atom of group 1 elements, hydrogen, lithium, sodium and so on, have one valence electron. So corresponding the 1 is 1A. Okay, so 1A means they have all the elements of group 1 one valence electron, such as carbon and silicon in group 4. So what is it? Number 4. So it means they all have 4 valence electron. Same thing in the noble gas, which is called group 8. So what is the number? 8. So it means in all noble gases or group 8A, how many valence electron? 8. Okay, valence electron are usually is the only electron involved in chemical bonding. As general rule, only the valence electrons are shown in electron dot structure. Remember one more time, valence electrons present in the outermost shell means valence shell. So electron dot structure are diagram that shows the valence electron in the atom of an element as dot, such as this. So see the table here. How many dots for hydrogen? 1. It means it's showing that in outermost shell of hydrogen have only 1 electron. Same look here, helium means 2 electron in the outermost shell. For lithium, 1. Remember, lithium atomic number 3, but 2 electron in the first shell and the third one, last electron, present in the outermost shell. So here only 1 dot means how many electron in the outermost shell. Okay, same thing, beryllium 2, boron 3, carbon how many dot? 4. So means 4 electron present. Nitrogen how many? 5. Okay, 1 1 and then these 2. Okay, one more thing I'm going to explain here so you can understand later on for the bonding. See, you can see here 1 2 3 electron is unpaired and 1 is paired. So altogether in outermost shell nitrogen have 5 electron because of the group 5. So dot 1 1 2 3 4. Okay, but where you going to put one more? It has to be with the other electron. So that's why it's become one paired electron and other one 3 going to be left as a single electrons. Okay, single dot. Now here, how many? 6. Oxygen has 6 valence electron in the outermost shell. So 1, 2, and then 2 pair. So altogether 2, 4, 5, 6. Okay, so 6 electron in the outermost shell. Group 7, you can see 2, 4, 6, and 1 electron left. Okay, now in the neon, you can see 2, 4, 6, 8. So how many dot? 8. So it means 8 electron in the valence shell. Now boys, you can see so on for the sodium, I mean period 3 and period 4, you can see all the way. So these are the representative element electron dot structure. Okay, this table shows the electron dot structure from the atom of some group A element. Notice that all the electrons within a group, with the exception of helium, have the same number of electron dot in their structure. Okay, see, look here, like this. How many? 1 electron. How many? 2 electrons. How many? 3 electrons. 4 electrons. Then 5 electrons. 6 electrons in the group. And group 7A all have 7 electron outermost shell. But here 8 except helium. Why helium? Because helium has only 2 electron maximum, atomic number 2. Okay, so except helium all are 8 electron. Now what is octet rule? The noble gases such as neon and argon are non-reactive in a chemical reaction. That is, they are stable. In 1916, chemist Gilbert Lewis used this fact of explain why atoms form certain kind of ions and molecules. He called his explanation the octet rule. So what octet rule says? The octet rule states that in forming the compound, atoms tend to achieve the electron configuration of a noble gases. Means every atom wants in outermost shell 8 electrons. Okay, because in noble gases, how many electron outermost shell? 8 to become stable. So every atom wants outermost shell 8 electron. So if they can lose or they can gain the electron to become outermost shell complete or become noble gases configuration. So an octet is a set of 8. Remember, octa means 8, set of 8. Atom of each of noble gases except the helium have 8 electron in their highest occupied energy level. And the general electronic configuration of ns2 np6 means number, n means number of shell, s means the subshell. Okay, next, atom of the metals tend to lose their valence electron, leaving a complete octet in a next lowest energy. Okay, so most of the or metals donate the electron, and because of this donate the electron, they lose the shell complete. Okay, so they lose the shell. So atom of the some non-metal tends to gain the electron or share the electron with another non-metal atom or atoms to achieve a complete the octet. Non-metal atom, they're going to share the electron. Okay, they are sharing the electron and they are losing the electron. Okay, remember this. Now draw the electron dot structure for bismuth, Pi. Okay, outermost shell, how many? 5. How the cation formed? An atom is electrically neutral because it has equal number of proton and electron. Many times we discussed in the last week and before last week. And ions form when an atom or group of atom loses or gain the electron. Means after the losing or gaining the electron, it become ion. So there are two kinds of ion we discussed already. One is called cation, other one is called anion. Now, how cation going to be formed? By losing the electron. Okay, student. Now let's see. A positively charged ion or cation is produced when an atom loses one or more valence electron, such as in group 1A, sodium. Okay, sodium atom becomes sodium cation by losing one electron, so that's why it's called Na plus, Na positive. Okay, calcium belong to group 2A, so calcium atom Ca form a calcium cation Ca2 positive. So it means how many electrons going to be lose? 2 electron. Remember this. So the most common cation are those produced by the loss of valence electrons from metal atoms. Most of these atoms have one to three valence electrons, which are easily removed. Okay, what is saying that group 1 making the cation by losing one electron, group 2 losing the 2 electron to become cation, group 3 normally losing 3 electron to become cation very easily. Okay, because of, you can see, they all want in the outermost shell 8 electron, but what is easy for them, to losing the 1, 2 or 3 electrons, or by gaining the 5, 6, 7 electron like this. So it's better to lose the electron. So that's why from 1 to 3, group 1, group 2 and group 3 all are metal. They are going to lose the electron to become cation. Now, when the forming of compound, the sodium atom loses its one valence electron and is left with an octet in with in what is now its highest occupied energy level, such as the number of protons in sodium nucleus is still 11. So the loss of one unit of negative charge produce a cation with a charge of 1 positive. You can see here, this is the electronic configuration. 1s2 means in first shell how many electrons? 2. 2s2 means in the second shell. So 2s2, 2p, 6. So altogether how many electron? 8 electron in second shell. So 2s and 2p combined together makes a second shell. Now in the third shell configurations you can see 3s1. Okay, means in third shell how many electron? Only 1. So this 1 electron going to be loose. When sodium lose this electron, it becomes sodium ion. Now you can see here octet complete. So how in the outermost shell you can see how many electron? 2 plus 6. How many electron? 6. So that's why it's called octet. So it completes the octet. Means outermost shell have 8 electron. By losing one electron of become sodium ion. So sodium ion has octet rule. And by the way, I'm going to ask you which noble gases configuration sodium achieved after the one losing one electron. Okay, good. This is neon. What is it? Neon. Now look here, boys. Both the sodium ions and the neon atom have 8 electrons in their valence shell, highest occupied energy level. Okay, you can see this is the sodium atom. We discussed this. 1s2, how many electron? 2. 2s2, how many electron? 2. 2sp, how many electron? 6. Okay, and 3s1, how many electron? 1. So energy level when increases, the outermost shell, this is called outermost shell. When it lose it, okay, loss of electron, so becomes sodium ion. So in the sodium ion, what left? You can see. So in 1s, same, 2 electrons, 2s, 2 electron, 2p, 6 electron. But in 3s, there is no electron because it loses the electron already. So sodium ion configuration and neon atom, as I told you, neon, okay, have same configuration. So after losing one electron from the outermost shell or valence electron, metal atom become ion, and this ion or cation is same as a noble gases configuration. The electronic configuration for any metal ion or cation is look like a noble gases electronic configuration. Now group 2A cation. In the group 2A, as I gave the example for calcium that they lose the 2 electrons. So look here. Giving the example of magnesium. Magnesium atomic number 12 belongs to the group 2A of the periodic table. So the magnesium atom have 2 valence electrons. So magnesium atom attains the electronic configuration of a neon atom by losing both valence electrons and producing a magnesium cation with a charge of 2 positive. You can see here magnesium, how many, this is atom, okay, magnesium atom, how many valence electron, 2, okay, by losing these two both electron, okay, it becomes 2 positive, and this is called cation. So magnesium ion, which is cation, lose the 2 electrons, okay, so 2 electron loss after become cation. Now the figure of the right list of the symbol of cation formed by the metals group 1a and group 2a. Cation of the group 1a element always the charge of positive 1. Why? Because they are all losing 1 electron. And cation of the group 2a elements always a charge of group 2 positive, because they all are losing 2 positive. So this is the periodic table, this group 1, group 2. So from the left side, group 1 always positive 1 ion and group 2 always positive 2 ion, because group 1 losing 1 electron, group 2 losing 2 electrons. The charge of the cation of the transition metals may vary. Yes, this is the bit different. Transition metal, remember group D block, okay, D block elements, okay, or B group. An atom of iron may lose its 2 valence electrons, forming the Fe2 positive cation, or valence electrons forming the Fe3 positive cation. Some ions formed by the transition metal do not have noble gases electronic configuration NH2 and P6, and are therefore exception of the octet rule, like a silver. Silver with the electronic configuration of 1s2, 2s2, 2p6, 3s2, 2s, 2p6, 3d10, 4s2, 4p6, 4d10, and 5s1 is an example. To achieve the structure of krypton, a silver atom would have to lose 11 electrons, okay, to acquire the electronic configuration of xenon. The silver atom would have to gain 7 electrons. Okay, so ions with the charge of 3 or greater are uncommon. So normally 3 or more is uncommon. So same thing here, a copper atom loses its ion, what is it, 4s electrons, to form a copper ion Cu positive with a pseudo noble gas electronic configuration as illustrated below. You can see this is the sodium copper atom. In it, 1s2, 2s2, 2p6, 3s2, 3p6, 2s1, and 3d, check here, 10, 2, 4, 6, 8, 10. Okay, so it lose this electron. Okay, loss of the valence electron. Okay, from here, 4s is outermost shell. Okay, and it become 1 positive. Okay, Cu positive ion. This is transition metal. Okay, fool's gold is composed of iron 2 cations Fe2 positive and disulfide ions S2 2 negative ion. Write an electronic configuration of Fe2 positive ion. So here we go. This is the normal atom and electronic configuration. After that, it lose the 4s2 electrons. Okay, so 2 electrons from the outermost shell become this ion, and this is Fe2 positive ion, or also called ferrous. What is it? Ferrous. Okay. Now, how does a cesium atom form a cation? Answer is by losing 1 electron, because cesium present in the group 1a. Now, formation of anion. How are anion formed? Anion is produced when an atom gain 1 or more valence electron. So note that the name of an ion of a non-metallic element is not the same as the element name, such as the name of an ion typically ends with IDE. Like in the cation, the sodium atom, sodium ion. Calcium atom, calcium ion. Magnesium atom, magnesium ion. But here, not like this. You can see chlorine atom, Cl. But when it forms the ion Cl negative, is called chloride anion. What is it? Chloride. So this is chlorine and this one chloride. Same thing happened here. Oxygen. Oxygen form oxide. So and with IDE. So oxide like a chloride, oxide, bromide, sulfide. So IDE. Remember. So anion ends on IDE. Now, atom of the non-metal and metallides form anion by gaining enough valence electron to attain the electronic configuration of the nearest noble gases. You can see this, all are non-metals. So, nitride ion, oxide ion, fluoride, then phosphide, sulfide, chloride, okay, like this. Okay, now let's take the example of chlorine. Atom of non-metallic element attain the noble gases electron configuration more easily by gaining the electron than by losing them because these atoms have relatively full valence shell, such as chlorine. Chlorine have 7 valence electron. So what is the easiest way for to become octet or noble gases electronic configuration? To gain the 1 electron or to lose 7 electron? Definitely to gain 1 electron. So a gain of 1 electron gives the chlorine atom an octet and convert a chlorine atom into a chloride ion. You can see the configuration 1s2, 2s2, 2p6, 3s2, 3p5. So in 3 means third or outermost shell, how many electrons? So 2 in the s and 5 in the p. So altogether how many electrons? 7. So in outermost shell how many electrons? 7 electrons present. So what is the easiest way to become 8? To lose these 7 to become noble gas configuration or to gain 1 electron. So easiest way is to gain 1 electron. So it gains the 1 electron. After gaining 1 electron, it become 3p6 and this is called octet complete. Okay, so this is called chloride ion. Okay, now chlorine atom gain the 1 electron to become chloride ion to complete their octet. Now, chlorine atom needs one more valence electron to achieve the electronic configuration of the nearest noble gases. This is the structure. Okay, you can see this is atom. So one is missing. By getting the 1 electron, it completes the structure or octet rule and to become like a configuration of argon. Now, the ion produced when an atom of chlorine and other halogen gain the electron are called halide ion. Means overall, like a chloride, bromide, iodide, all are group 7, also called halogen. So halogens, when it gain the electron, halogens called halide ion. Okay, so all halogen atom have a 7 valence electron and need to gain only 1 electron to achieve the electronic configuration of a noble gas. All halide ions like a fluoride, chloride, bromide and iodide have a charge of 1 negative. Now go for the group 6. Oxygen is the group 6A and an oxygen atom has 6 valence electrons. Oxygen atom attains the electronic configuration of a neon by gaining 2 electrons. So you can see here 1s2, 2s2, 2p6. In the 2p6, how many here? 4. Okay, so you can say 2p4 here. Okay, but after gaining 2 electron, it become 2p6. So outermost shell, how many? 2s, 2p. 2 plus 2 plus 2 is 4 in atom. But here you can see 2 plus 2, 2 plus 2, plus 2 and plus 2. So altogether 8 electron in outermost shell. So when oxygen atom gain the 2 electron, it become oxide ion, and in oxide ion outermost shell is completed by 8 electron. And this after the gaining the electron, oxide ion configuration, electronic configuration same as the neon. Now this is the table list some common anion. Fluoride -1, chloride, bromide, iodide all -1, oxide, sulfide -2, nitride and phosphide -3. Means these all are gaining 1 electron, these gaining 2 electron, and those going to gain the 3 electrons. What is the electronic configuration of sulfide ion? What noble gases share this configuration? This is checkpoint. Answer please. Here we go. This is the answer. 1s2, 2s2, 2p6, 3s2, 3p6. Okay, this is the same configuration as argon. Okay, students, now this is the end of the 7.1 lesson number 7.1, and thank you so much. And any question you can ask in the discussion. Thank you.